Hi and welcome back to a new video. You maybe also saw some news in the past few months about improved 12-volt high power cables. For example, there is this ASUS ROG 90-degree angled cable with integrated temperature sensor, or the SegoTap Titan load cable that is supposed to achieve much low temperatures during operation. Now ASUS ROG claims similar things with the ROG Equalizer, which is a cable that is supposed to also achieve lower operating temperatures and at the same time have a more even current distribution across the pins. If this actually works and if this is a product that makes sense is something I want to test today. Thermal Grizzly Duronaut is our new high-end thermal paste and the successor of Cryonaut. It's even better performing, it is much easier to apply, it is cheaper and it's much more durable. That's where the name comes from. Especially if you're now maybe considering to buy a new PC, then I would highly recommend that you're looking into this thermal paste. So let's continue with this video. I received 2 of those cables so we can test them and also see if it actually helps, and then later on maybe even cut one open to see what it's actually built in. Because what should not be inside is any kind of active circuitry. Because when I first saw this, I was like, not quite sure what it's actually doing, the ROG Equalizer, because they were claiming balanced power delivery in one of the first marketing things they sent to me. But then when I was digging deeper into the product, I couldn't find any active circuitry. So it's not really active load balancing, so it shouldn't do that. But there's also more to it. First of all, it is supposed to be a high quality 12-volt high power cable. And today we will compare it with the one that comes with my Seasonic PX2200, which is also a very high quality PSU and should also be a high quality 12-volt high power cable. If we measure the diameter of the Seasonic cable, it is reading 2.4 millimeters. And if we measure the ASUS cable, we are reading about 2.7 millimeters. And also going by the Seasonic specs, we know that this is a 16 AWG cable, but I don't really know about the ASUS one. We measured the diameter also including the insulation of the cable, and 2.4 to 2.7, it could be the difference from 16 to 14 AWG, so this one could be increased cable diameter. But I'm not 100% sure, simply because I'm also measuring the insulation and I just simply don't know how thick the cable is inside. Since I wasn't sure about the cable diameter, I double checked again with ASUS. They confirmed it's an AWG 16 wire, so that is also standard. The different diameter can just be caused by a different insulation thickness. What's quite unique about this cable is this front part. And first I thought this is just a weird or like nice fancy looking cable comp. But it turned out to be a little bit more than that. I then reached out to ASUS again to figure out what they actually did and if there is anything more to this thing. And they said they developed a new mechanism to connect the cables. And I'm not sure if this is like mechanically or also electrically. Like mechanically, it would make sense to just fix the cable at this point to prevent them from further movement. When you plug in the cable, that the pins just can't come out, right? Giving this more mechanical stability makes sense, but also electrically it could make sense. And I mean, there's an easy way to figure this out. We can just measure this with a multimeter and see if it's also electrically connected. We can simply check this with resistance. Can you hear it? If we have direct contact with the multimeter, and I mean, that makes sense that it has contact. But you can see all of them. All of the 12-volt pins are connected with each other. It's obviously not connected with ground. That makes sense. And now ground to ground. Yeah. Also, all ground to ground pins are connected with each other. So it's not only mechanically, but also electrically, all the pins are connected with each other. This means that ASUS in the ROG Equalizer added another layer where all the 12-volt pins and all the ground pins are connected within each other. But that's not super new. That is also what NVIDIA is doing in this connector, the connector that you should know, the adapter. And if you're thinking, okay, this might be the game changer, I don't think so. Because we used the same technique on the older WireView, we had this special connector on here where all the 12-volt and the ground pins were connected directly on the connector. So through this big piece of metal right here, we had all the 12-volt pins and all the ground pins connected. And as you can clearly see on this one, this is one with a burn connector, and we had a couple of these. So if it was that simple to solve the 12-volt high power issue, these cases would not have happened, right? But they definitely happened. But to be fair, it's not exactly the same on the equalizer, because they have this electrical connection shortly behind the connector, but not directly at the connector. We had this on the WireView and also on the NVIDIA adapter, that you have a very rigid, a very solid connection. So you have electrically and mechanically all the pins connected within each other, like on top of the connector. The same thing on the WireView, right? So there's not a lot of flexibility when it comes to the pins. If you plug this into your graphics card, the individual pins, they can't really align much because they're just rigid, right? They're solid. There's nothing that can move. But here, even if it's not much, but we have like 12 millimeters of cable on top, just after the electrical connection. So it might allow the pins just a little bit of movement, and that could help. What could help though is the fact that this is also mechanically quite rigid. So you can't really move the pins in this direction because they're all sitting very close to this thing, whatever it's called. And you can't really move the pins in that direction. You can move them a little bit left and right, but not much. And you can't move them in this direction, which could definitely help. And this is the Seasonic cable I had a few issues with in the past. That's also what I used for showing with the WireView Pro 2, for example. And if you just pay attention to this, I mean, this is common knowledge, right? I mean, we all know about this. It's nothing new, but you can see that this moves. And you simply don't know if you're plugging in the cable, is this causing issues? Does this matter? Does it not matter? But you can see it's moving. And this movement is not possible on the equalizer. The test setup is obviously with RTX 5090 and also WireView Pro 2, so we can track how even the current distribution would be with the ROG Equalizer. And I also want to point out that this will be a negative example. I used this cable in the past and I know this one is bad. I know it for sure, and obviously if I would replace this one, it would be better. But we want to show how it looks like when it's not great, so we just fire up Firmark, and then we can see that this one, yeah, you can see it's giving us like 5 amps on one pin, 11 amps on the other pin, and then you're just waiting to see the current imbalance warning, which it's also throwing now, so that is totally expected. I also disabled the buzzer on this one for this, alarm, so we don't get annoyed, but yeah, this would be like a bad example if you have a bad cable. It's been a couple of weeks that I have been working on this topic. I just reset up the entire system. It's still the same GPU, the same WireView, the same PSU, but you can see I'm using a different cable. That's just a Delicon cable that I bought on Amazon, just to show that with a normal cable, this setup is fine and not outputting any kind of errors. We're seeing normal current distribution as expected with the 5090, something between 7.6, 8.3, 8.4 amps. So that is a normal current distribution that is expected. Now I'm switching back to the faulty Seasonic cable that I've been using, and I'm also using the same connector on the PSU because it has two 12-volt high power outputs. And now I'm running Firmark again, and you can see that this distribution again does not look great. We see 4 amps on one pin, like 10 amps on 2 pins. So you can definitely see that this is caused by the cable. There is a time gap for me in this video between what you saw so far and this part of about 3 weeks, because I was testing everything until the point of testing the Seasonic cable as a negative example and the Delicon cable as a normal performing cable, and then I was testing the ASUS Equalizer. And I was honestly a bit surprised by the results, and you will see why. ASUS Equalizer is connected, still using same PSU, same port on the PSU as well. The only thing I can't connect, because this is specifically meant for Thor PSU, is this one, but I will later talk about what this dual pin connector is about. And again, running the same Firmark test, and then you can see the current distribution. Lowest pin is about 7.1 amps, highest pin is about 9.2 amps. Which is actually higher than the much cheaper Delicon wire that I bought off Amazon. And after I found exactly this about 3 weeks ago, I reached out to ASUS again and said that this is probably not what people would expect when they buy the Equalizer cable, and they might use WireView or other third-party devices that allow current measurement, or even just the Astral card, which has the current distribution measurement built in. And meanwhile, I also received more cables, so I have a total of 3 Equalizer cables now, and I also have the original cable that was included in the Thor PSU, and I will now just measure them after each other, throw everything into a chart, and then we can look at the results. And that's why we will continue with the Equalizer number 2. I also marked them so I don't mix them up. You can see it's a very similar current distribution just across different pins. Previously it was pin 6 that was highest, now it's pin 5 that it's highest. And now the craziest, or I would say worst, last, which is cable number 3, which is even throwing an alarm on my WireView. And that was for me also the alarm why I originally reached out to ASUS. And as you can see, the distribution is much worse. Like highest pin on number 1 and then 2 and 3 are much lower. And now the last reference, which I never checked so far when it comes to the current distribution, which is the one that is originally included in my ASUS Thor PSU. And here again we have a much more normal current distribution, which is very comparable to the cable I bought off Amazon, the Delicon, I don't have no clue. But this is also showing between 7.3 to like 8.2, 8.3 amps. And in case you think this is related to the PSU, and you could argue, A, you didn't use the Thor PSU, which has this extra connector, whatever this is for, right? That should not be the case. Every PSU is regulating its output voltage. Ideally, for example, you would have 12.0 volt output on the 12 volt high power connector. Then you have a series of resistances that can be the contact resistance to the connector, then the resistance of the wire, again contact resistance to the GPU, and they all add up, which leads to a voltage drop. This voltage drop is normal, is expected, and that's why even if your PSU delivers 12.0 volts, you will get something like 11.8, 11.7 volts on the GPU. That is absolutely normal and no problem at all for your GPU. It doesn't really make any difference. It will have a slight difference on the current, but not on the current balance. And what ASUS is doing with the equalizer cable, it's also what they did with the Thor cable before, is that this is an additional voltage sense wire, and it's taking the sensing point from the output connector of the PSU to the front of here. So let's say in a normal scenario, you would have a voltage drop of 0.2 volts to here. Then the PSU can just regulate a bit better with this external voltage sense. But this has no impact on your current distribution. Just absolute values of the current might change a little bit, but it won't help you just when it comes to the current distribution. In this table, you have the overview of the cables that I tested. Seasonic PX2200 cable, the one I know which has issues, has a very high current on pin number 4 with 10 amps and very low current on pin number 6 with 4.4 amps, which leads to a delta of 5.6 amps from min to max pin. Delicon, not sure, but this one has the lowest pin on pin number 1 with 7.6 amps, highest is 8.3, which results in a delta of 0.7. Very similar to the ASUS Thor that was originally included in my Thor PSU, has a min-max delta of 0.6 amps. Equalizer number 1 has the highest current on pin number 6 with 9.2 amps and a delta of 2.1 amps. Equalizer number 2, very similar, but with the difference that the highest pin is the pin number 5, 9.2 amps, and has a delta of 2.0 amps. And equalizer number 3, the one which even triggered the WireView, highest pin number 1 with 9.8 amps and a delta of 3.6 amps. Looking at those results, you will probably think that this is not too great, especially being under the expectation that having this kind of bridge directly in front of the GPU will lead to a much better current distribution. But that can actually be a misconception. And to better understand why, we will look at this example in theory. So we have a PSU on the left that is connected towards a normal 12 volt high power cable. So we have some contact resistance here. Then we have the wire itself, which also has some resistance inside. And then we have a GPU on the right, which also then has some contact resistance from the cable to the GPU. And that's also what you can see here. On the left we have the PSU that outputs 6 times 12 volt wires, and you can also see the connectors here. And here we connect the cable. And then on the right we have the GPU. And this is again connected to the 6 12 volt wires. Of course this is very simplified, but it should contain all the major components or resistances to understand what's going on. We have our connector for contact resistances and our wire for the resistance of the wire itself. Now for this example, I took some values that could actually happen. So for example, on the PSU side, we have contact resistances in the range of 1 to 2 milliohms. Then we have a wire resistance of 6 milliohms and again contact resistances on the GPU side of again 1 to 2 milliohms. Again, this is very simplified, but it will help us to understand what this bridge is causing in the cable. Now all those resistors in the end will add up because it's just a series connection of resistors. For example, this will lead to a total of 8 milliohms or 10 milliohms. And this series of resistances will determine your current distribution. And for this specific example, we would have a current distribution from 7.3 amps on the lowest pin and 9.1 amp on the highest pin. In my example, this will lead to a current difference of 1.8 amps, which equals about 20%. That is a very realistic scenario and something that is definitely happening in a lot of systems. And this is caused by the series of all the resistances that come from the PSU to contact resistances wire, and then what's happening in the end on the contact resistance again on the graphics card. Now on the equalizer, this chain of resistors is much shorter. It's only this bit in front. Going back to our example, you can see that there is now this bridge, which is very close to the GPU side and connecting all the 12-volt pins together. We will now go with the same values that we had in our example before. So same contact resistances of about 1 to 2 milliohms from the connector to the GPU. Now interestingly, this leads to a much more uneven current distribution. We see 5 amps on the pins that had the high contact resistance and 10 amps on the pins with the lower contact resistance. This means we see a difference of 5 amps between the pins. So that means 2 pins carry 50% less current than the others. And that could be the misconception, because you would assume that this kind of bridge so close to the GPU would cause a much more even current distribution, which is not necessarily the case. That is also something I had about a year ago when there was this big NVIDIA interview drama where NVIDIA claimed that with their adapter it can't fail because they have this bridge basically built into the connector, and this would cause always a very even current distribution. Now unfortunately it's not that easy to claim that this is now obviously worse than before. That's not exactly the case. So it's just giving us a completely different scenario. Instead of the entire chain of resistors, we now have 2 chains. We have just something in between that is splitting up the PSU side and the GPU side. Now if you use a normal wire, for example, we take this one, you can see, it's obviously connected on the PSU side and on the GPU side. And let's just assume this would have 15 amps caused by a bad connection on the GPU side. Then this wire would always carry the 15 amps and would also have this on the PSU side. So with a very bad connection with a normal wire, you would always automatically damage both ends. We saw those things a couple of times in the past when it was a really bad case that both ends were damaged, like both GPU and PSU had damage on the cable side. And that is something that is very unlikely with the equalizer cable if you have this bridge in between. Now what does all of this tell us about the equalizer cable? Honestly, not too much. At least I can't really judge it. So we had, for example, this higher current distribution between the pins when using the equalizer cable, which is electrically expected. We had one of the cables exceeding even the 10 amps. Now ASUS says that this is absolutely no problem and also expected. They also say that it's expected to have a higher current imbalance because of the bridge that is being built in. They say it minimizes the risk, which electrically makes sense, but they also say that the higher current is no issue because they claim the cable can carry up to 17 amps per wire. That is something I simply can't verify. I have absolutely no way of doing that and telling you that this is good or not. They claim that they changed the contacts in the pins itself and did some enhancement to it. They changed, for example, to a different plating. And this is definitely something I want to check in a follow-up video, probably on Sunday, where I want to take a closer look at the contacts, at the material, at this bridge that is being built in. And then maybe we can just get a better understanding of the changes they did. But there's simply no way that I can tell you that the 17 amps make sense or are safe. ASUS says that the 17 amps are safe, and that's all I can tell you. I can't really judge. We would probably have to assemble 1,000 systems and then see if it burns or not. And that is something that's out of scope for me right now. So for the moment, all I can tell you is that this seems like a higher quality cable. It will probably lead to a higher current imbalance, which ASUS says is expected, which is expected probably because of the bridge as well. And they claim it's no problem because the cable itself can carry up to 17 amps per wire because of the improved contacts of the contacts themselves. And that's something we want to check on video on Sunday. So much about this video or cable so far. Hope you still enjoyed this. See you next time. Bye-bye.